So previously we discussed about the equivalent circuit as referred to the primary side and is referred to the secondary side. So now we have to know the approximate equivalent circuit. So in that we are going to represent as that is a no load branch, that is exciting branch is in between the Z1 and Z2 dash. So the impedances can't be combined. So further simplification of the circuit can be done is we need to draw the approximate equivalent circuit. So in this equivalent circuit can be further simplified by the shifting the no load containing R naught and X naught. So basically this no load component in between the Z1 and Z2 terminals, either we are going to represent as Z1 dash into Z2, either we are going to represent as Z2 and here Z2 dash and Z1 terminals. So based on that we are going to represent it. So in between we have the no load component. In this no load component we need to represent as approximate equivalent circuit we need to draw. So in based on that the equivalent circuit can be further simplified by shifting the no load containing the I naught component, it represent as R naught and X naught to the left of R1 and X1. So basically we know the equivalent circuit. For example, I am going to consider so the primary terminals are as usually we can represent like this only. All the terminals are shifted to the secondary side. So now let we are consider it. So based on that we are going to represent the equivalent circuits. So here this is I naught component and we are going to represent as X1. Here I am going to represent as IM, and this is IC component, here the magnetizing component. This is the resistance R naught, here I am going to represent X naught. So all the components is secondary terminals are shifted to the primary. That means E1 is equal to the E2 dash. That means here I am going to represent as R2 dash and the X2 dash, and here we are going to represent as a load, that is Z2 dash, and here I am going to represent as V2 dash. So in between we have to write down the equations. So these R naught and X naught, here we are going to represent as R naught and X stands to be left of the R1 and X1. So by doing this we are creating an error that the drop across R1 and X1 due to the I naught is neglected. So based on that we are going to shift it to this R naught and X naught is to the primary side of the terminals, that means is left of the R1 and X1. So based on that we need to draw the equivalent circuit is called as the approximate equivalent circuit of the transformer. So now we have to represent as the approximate equivalent circuit referred to the primary can be represented here. So whatever I am going to represent this, I will draw the approximate equivalent circuit. So whatever the terminals are there here, this is shifted to the left of the R1 and X1. So now I will draw the approximate equivalent circuit here. That means first of all I am going to represent as no load current, that is the resistance and the reactance. So in this I am going to represent IM, and here I am going to represent IC. This is R naught and X naught terminals will be shifted to the left of the R1 and X1. So based on that whatever the terminals are we have, so as usually we can represent as I2 dash. So then we are going to represent as R2 dash, and the reactance is X2 dash. So the low terminal we are going to represent it. So that is V2 dash is equal to the V2 by K, and the ZL low terminal. So based on that this is approximate equivalent circuit. So these equivalent circuit can be further reduced by combining the parameters R1 and R2, because here this is a resistance R1 and this resistance R2 is series, and X1 is X1 and X2 dash is connected in series. So we can combine the parameters R1 and R2 dash, and that we are going to represent as R0 equivalent of 1. The parameters and X1 and X2 we are going to represent as a X0 ones. So based on that only we need to represent as that R01 and X01 are equivalent resistance and reactance of a transformer referred to the primary side. So we can draw this is the no load component I0, and here I am going to represent as R0. It flows in the IC component, active component, the reactance X0, the IM component will be represented. So in this I am going to represent as that is R01. That means here we are going to represent as R1 plus R2 dash. That we are going to represent the reactance term, that is X01 is equal to the X1 plus X2 dash. So based on that we are going to represent as the impedance, that is ZL dash. So I am going to draw like this. So based on that we are going to represent as V2 dash only, because all the secondary terminals we are going to shift it to the primary side. So this is approximate equivalent circuit referred to the primary side. Approximate equivalent circuit referred to primary. So in this I am going to neglect this no load component I0 is only about 3 to 5% of full load current. So we can omit the parallel circuits R0, X0. So without introducing an appreciable error in the behavior of the transformer under load conditions, such that we can removing this complete part, then we can draw the approximate equivalent circuit referred to the secondary. The approximate equivalent circuit referred to the secondary side is negligible no load current I0. So we can draw the approximate equivalent circuit. So that is the resistance and the reactance and the impedance ZL dash. Here we are going to represent as that one R01 and X01. Here the primary we are going to represent as V1. Based on that the primary current I1, that is equal to the I2 dash. So this is all about the approximate equivalent circuit is referred to the primary side. So in a similar manner we can represent as all the components is referred to the secondary side. So we can represent as the resistance R02 and the reactance X02. Based on that we are going to represent as I1 dash is equal to the I2. Then the primary is shifted to the secondary side, that's what we are going to represent as V1 dash. So based on that the impedance ZL we are going to draw like this. Then the secondary terminal voltage we can represent as V2. So this is all about the approximate equivalent circuit is referred to the secondary. So this is referred to the primary. So this is all about is referred to the secondary. So today lecture is this complete equivalent circuit of a transformer and approximate equivalent circuit of the transformer. So why we have to draw on this one? Because of to easy simplification of point of view, we need to draw the equivalent circuit of a transformer. Thank you.